Now we will move on to the beginnings of real primate field studies. Lecture 7, Presentation 2. First systematic primate field research before Jane. Today we understand the problems with these earlier studies. Why? Field studies on non-captive primates in nature. They have provided insights that you could not gain from captive studies. When did field primatologists come into the picture? Well, most non-human primates occupy tropical habitats. Prior to 1945, that is the end of World War II, travel to and communication from tropical regions was nearly impossible, and there were few, if any, treatments for tropical diseases, malaria, yellow fever, dengue fever, blackwater fever, and so on and so forth. In addition, provisioning and resupply in the field was challenging. There was no refrigeration, no electricity, etc. Field research was dangerous. There had been one 7-week study on chimpanzees in Western Africa in 1931. But prior to 1945, that was about it, with one remarkable exception. The first systematic primate field research, Carpenter. In the 1930s, C. Raymond Carpenter initiated the first lengthy scientific investigation of primates in the wild. He demonstrated that field work was doable and invaluable. Carpenter's research began in Panama, where he established field methodologies in use to this day. He employed comparative methods, and this provided information on both intraspecies and interspecies variation. Carpenter's first study focused on the social behaviors of howler monkeys. He gathered comparative data from their closest relatives, the spider monkeys. Thus, important differences in adaptive variation could be assessed. Howler monkeys were larger bodied than spider monkeys. Both had prehensile tails and both were strongly arboreal, but the howlers focused on the consumption of leaves, they were fullivorous, and the spider monkey focused on fruit collection, it was frugivorous to omnivorous. The howler monkeys lived in large social groups and were very loud, hence their names. Spider monkeys, on the other hand, have very small group sizes. They break up for small individual foraging parties for a complex social system known as fission-fusion, and they are quiet. Thanks to his field accomplishments in 1937, Carpenter was included in the Asiatic Primate Expedition, APE, in Thailand, where he became the first researcher to study gibbon behaviors in the wild. So he's really our first ape field primatologist. Primate Field Research and Evolutionary Studies, Carpenter, Schultz, and Washburn. The APE project included 2 biological anthropologists, the superb Harvard University primate anatomist Adolf H. Schultz and his young graduate student. Thus, the pioneering field primatologist Carpenter and best primate anatomist of the day, Schultz, were together in the right place at the right time to influence the future father of American primatology. Schultz's grad student was Sherwood L. Washburn, and if you'll remember back to section 1 of this course, Washburn was one of the folks who brought the modern synthesis, the marriage of Mendelian genetics with Darwinian natural selection, to anthropology. From Schultz, Washburn learned about primate morphology and how bones and joints are shaped for and by behavioral adaptations. From Carpenter, Washburn learned the value of studying primate behavior in the field. That is, you could put the behavior together with the anatomy. Primate field research and evolutionary studies, let's focus on Washburn. In 1940, Washburn earned the first anthropology PhD at Harvard University on the basis of a doctoral dissertation on primatology. Washburn was the academic who brought modern evolutionary theory to anthropology, shifting its focus away from descriptive exercises to adaptive studies of variation. In addition, Washburn brought anthropology to primatology, giving emphasis to morphological and field behavior studies. From Sherwood L. Washburn, we learned that when functional anatomy and behavioral data are combined, they can provide insights on primate adaptations that can be applied to studies of extant and extinct species. So let's start over on the left-hand side, and this is from my own research, and what you're looking at is a footprint of a gorilla. This is Bwana, and I took this footprint and I saw right away that there was something very strange about it. There was this line right up the middle of the foot, and when I did dissection, I found out that more than 50% of the foot's musculature was given to operating the big toe. And then the rest of the musculature operated all four of the other toes. Let's go over to the right-hand side and look at a human foot. With the human foot, you do not get that divide down the middle, and you do not get 50% of the musculature operating that one set of toes and 50% for the others. Instead, what you get is a whole complex of muscles that operates all 5 toes. Now, in the center, we have a fossil human footprint. This is a trace fossil. Trace fossils actually document behavior. And what we see is that we have the pattern of the single operation of muscles for those toes as we have in the modern human foot. Thus, what we have is not the foot of a knuckle-walking ape, but the foot of a bipedal human in the fossil record 3.6 million years ago. And so, how did I gain this information? It was a combination of anatomy together with behavior, known behaviors. And that's exactly the viewpoint of Washburn. And that was the information that took me to the next level in graduate school. So we go from Washburn to Zillman to Nichols to you. So you are third generation Washburnians. Here is Washburn up here. And I'll use purple because that's Adrian's favorite color. So here is Washburn. Here's Adrian Zillman. Here's Adrian Zillman. Here I am. And there you are. So you are third generation Washburnians trained in the same methodologies and perspectives as given by Washburn. Primate field research and evolutionary studies. Following the end of World War II, 1945, primate field research profited from improvements in transportation. Field vehicles like the Jeep were a huge improvement. And there was communication from the field and treatments for tropical diseases. That's a very important and underwritten part of what happened with World War II. Many of the people who served in the Pacific Islands in particular, or the Pacific Theater, had problems with malaria and all sorts of stuff. The military had to figure out how to treat people, and I understand that more service people died from malaria than from being shot in World War II. Together with modern evolutionary perspectives, field primatology began to come into its own. Now you could treat for health, you could get your food, you could communicate with the outside world, and you could get around. In 1948, the first decades-long continuous primate field research project on a single population was initiated in a surprising, for primates, place. Most non-human primates inhabit tropical zones. Well, macaques did not get the memo. The numerous macaque species can and do occupy nearly every habitat from North Africa, across India, into Southwest Asia, into high-altitude Himalayan biomes and westward into the cold weather of Japan. Primate Field Research and Evolutionary Studies, Kinji Imanishi. In 1948, the key founder of Japanese primatology, Kinji Imanishi, initiated the first long-term field research study in primatology. He studied wild Japanese macaque populations on Koshima Island. Imanishi was the first to identify individual primates in a study population. He used number identification, but this was a big breakthrough moment. So recognize he was the first to identify individuals using a numbering identification. Jane Goodall later names individuals. She doesn't use numbers, but he was the first to do this. When he reported that he and his students could identify 100 individual monkeys by appearance and personality, there was huge resistance. Many researchers did not believe that non-human primates or any non-humans had personalities. However, another field primatologist, good old Carpenter, fully believed him and supported him. In this image, Carpenter is holding the inaugural volume of the first peer-reviewed scientific journal for primatology. It was known as Primates, and it was given to him by its first editor, Imanishi. This is a very interesting set of journals. It was originally recorded in Japanese, and it was so popular among primatologists all over the world that they were having people translate out of Japanese into English so that they could understand the publications. Pretty soon it became so obvious that people needed a translation into English that the journal transferred over into English. So back to Imanishi. By identifying individuals, Imanishi was able to document the transmission of a new behavior within one population and across the generations. The behavior began in 1953 when one female macaque, an individual numbered as F111, began washing her potatoes before eating them. Now, think about this for a moment. A lot of times students think that they're washing the potatoes to clean them. She was using salt water. This locality was on the ocean. And have you ever eaten a potato without salt on it? It's pretty gruesome. Macaques are closely related to us, and I suspect they have the same kinds of taste buds and would prefer salt. And salt is a very difficult item to get in nature, and you need salt to survive. So she picked up the habit of putting salt on her potatoes. Other individuals in the population picked up the behavior, and it spread to the next generation of macaques. By 1962, over 70% of the study population regularly engaged in potato washing. Even though F111 and her peers are no longer alive, their descendants today engage in this behavior. This is the only Japanese macaque population known to potato wash. Imanishi pioneered long-term field research and inspired numerous field primatologists, and was one of the first to suggest that non-human primates exhibit culture. Over the last decade, his hypothesis has gained support. Primate Field Research and Evolutionary Studies, Cold Spring Harbor Symposium, 1950. One very important event occurred in 1950. A symposium was held at Cold Spring Harbor in New York, which brought together the most important evolutionary scientists in the world. Among others, Ernst Mayr, remember he gave us the biological species concept, Washburn, and Louis Leakey, who is the well-known paleontologist, archaeologist from Olduvai Gorge in Tanzania. The researchers had diverse interests in genetics, population biology, anthropology, primatology, paleontology, morphology, and human evolution. Together, they presented a new reason for studying primates in the wild. Non-human primates can act as windows into the human past. Where non-human primate adaptations overlap with human adaptations, it likely reflects shared ancestry. Where human adaptations differ from non-human adaptations, it provides insights on what makes us human. After Cold Spring Harbor, paleoanthropologists began sponsoring primate field research. Specifically, Louis Leakey was particularly interested in chimpanzee adaptations. He wanted to find a researcher who would study a wild chimp population at Gombe in Tanzania. After several unsuccessful attempts by male researchers, Leakey decided that a female researcher might be more successful studying chimps in the wild. One of the thoughts on this is that the chimpanzee males viewed the male researchers as merely another form of chimpanzee, and they were very aggressive toward them. Chimpanzees will attack outsiders who try to come into the group. Another aspect of this that may have been in play is that the male researchers weren't good at thinking about how the chimps were responding to their behaviors, and so they caused the chimps to become aggressive. Well, Leakey knew a young woman who seemed to be the perfect candidate for the job, and she wanted nothing more than to study chimpanzees in the wild. Now you are ready for Lecture 7, Presentation 3, Jane Goodall.